So in this case, we are going to consider a continuation working with the different condition this time where we have got a division, two functions, all right, f of x over gx, which can be greater than 0, it can be greater than or equal to, it can be less than or equal to 0. All right, remember we have got a fraction. Given a fraction like this, and it is an inequality, which is true, very, very true. But whenever a fraction is given, consider that there are values that we must work with. What am I trying to say? The denominator cannot be equal to 0 in whatever sense that you're going to have. K over 0, remember, it is what? Undefined. A constant, whatever that you have, as long the division, as long the denominator part is equal to 0, this one, everything becomes undefined, invalid, cannot be simplified. So meaning that is the first thing to put into consideration whenever you are to solve for x. To determine the values of x, you must consider to say the denominator cannot be equal to 0. So in our case, since we are using gx, we are saying gx cannot be equal to 0. The denominator cannot be equal to what? Cannot be equal to 0. So we must take note for the x values, which will give us this y to be a 0. That value, or for any other value that you be given, you must take note that this cannot be equal to 0, the denominator. All right. What about the critical values? As we had before, remember, everything lies on the critical values. Whenever we have got a comparison where it is a division or a multiplication like what we had in the previous class, our critical values will be the intercepts, which is what? The x-intercepts. So you focus on the x-intercepts. When we have a hyperbola, there you must consider what the asymptotes and see what is happening. The asymptotes should be also put into consideration. But for any other normal graph or function that we are used to, besides a hyperbola, we must consider the x-intercepts. So that is it. It is just a comparison. Just a comparison. To get a positive, as we have got a division, in order for us to get a positive value, it is either we are going to have a division of a positive over a positive. Positive over positive, that will be positive, or it can be negative to a negative. When you are dividing a negative over a negative, you get a positive. To get a negative, it is either we are going to divide a positive to a negative or a negative to a positive. We are going to get a negative, just like what we had on the product. So I'm not going to waste your time because we had similar questions, only that they were under a product. All right, this time is just a division. So I'm just going to use a similar diagram. We had actually a diagram of this nature in our previous class. So I'm just going to work with that one so that we do not waste our time, guys. In this case, we've got our f of x and also the g of x. Let's say this is our f of x, which is a parabola, just like what we had before. These are the x-intercepts at -4 and +1. Then there is a linear function, which is something like this, all right? So that is what you're given. So first one, it is f, and this is our g. and this is our G. Okay, so that is what we are given, and these two, they intersect here and also intersect here, which is not important as the x-intercepts are the ones that matters. So x-intercept here, x-intercept there. All right, let's say the question was, all right, let's say we are given, the first question is to determine the values or values of x, the value or values of x for which f of x over gx is less than 0. All right. So that's being a negative. So they can say less than or equal to 0. In that case, it is the numerator which can be equal to 0, not the denominator. 0 over k gives us a 0. But k over 0, this one does not exist. Okay? So we can have an equal to. It's not like we're not going to have that equal to. Okay? So like I said, this type of a question is just a comparison that you are going to make where the critical values are the what? Are the x-intercepts. So in our case, we have got -4 as our x-intercept. I think we talked about this type of a graph. So -4 and at what? At 1. Those are the major points that you're going to look at. So we have got this side, we've got this part, and also this part. All right. So let us judge according to what we have on the diagram. To get a negative, it's either we're going to have positive to negative or negative to positive on our division. So let's check what is happening from -4 going to the left. All right. From -4 going to the left, we can see that our f here is above the x-axis. Remember, to be positive, we are saying according to the x-axis, what is above is what is positive. Remember that. So in our case, f is positive since it is above, and our g is found below. That's a negative. So this is exactly what we want. A positive divided to a negative. It is going to give us what? A negative. So meaning to say this region actually satisfies our solution. Let's move on from -4 up to 1. What is now happening is that the f is below the x-axis. This is our f below the x-axis being what? A negative, whereas g is found above the x-axis, all right? Which is what? Which is a positive. Positive to negative, this is exactly what we want. All right, this is exactly what we want. So this region also satisfies our solution. From 1, this one here going to the right, 1, 2, and so on, if we check, both functions are above the x-axis. This one, it's above being positive. Our g is also above being what? A positive. So positive divided to positive does not give us a negative. So this part does not satisfy our inequality. So the regions that we are going to use which satisfy or which do satisfy our condition in this case will be this part and also this region. Those are the two. All right, from the x-intercepts. So therefore, in our case, the solutions were going to be what? -4 to the other side, that is less than. So x is less than -4, or in between -4 and what? At 1. So that's x is greater than -4. But less than what? But less than what? So this is the condition. This is our condition. So I want us to be very careful. If they said here, f of x over gx is less than or equal to 0. It does not mean you're going to put equal to here, you put equal to here, you put equal to here. You must consider your gx. It is the one in the denominator. Remember, I said for the fraction, you must be very careful. Gx cannot be equal to 0. This is our denominator. So if they put an equal to like that, you must consider it as an individual to understand the denominator concept. Since they have equal to, it does not mean put that equal to again, because gx can never be equal to 0. So now, if we consider what is happening at -4, -4 at that point, -4 here, both f and g will be what? At 0. Remember, in the x-axis, y is equal to 0. So at -4, f here at -4 is 0. G is also 0 there. They are in the x-axis. Y is equal to 0. Both. So meaning to say, y cannot, our x cannot be equal to -4. Because at -4, g will be equal to 0. Gx will be equal to 0. Y will be equal to 0 there. So definitely x cannot be equal to -4. X cannot be equal to -4. So if x cannot be equal to -4, it means as part of our solution here, we cannot write x is less than or equal to -4 because x cannot be equal to -4. So therefore, our solution is just going to be x is less than -4. We move on to the other part, which is supposed to be x is greater than -4. So it is supposed to be x is greater than or equal to, but remember, x cannot be equal to -4. So it will be just x is greater than -4. Less than what? Less than 1. Let's check on this part of being less than 1. Is it limited at 1? At 1, this is 1 here. At 1, it is f which is equal to 0 at this point 1. F is the one that has got what? An intersection with the x-axis there. It is the x-intercept for f. It is the one which is at 0. F is 0, like 0 over. But what is happening with the g at that moment, direct where x is equal to 1, we can see that g is equal to a certain value that we do not even know. So 0 over whatever that we do not know there, it is going to give us a 0. This one exists. G is not affected. G is not affected. It is not G which is equal to 0. It is F which is equal to 0. So if the numerator, guys, if the numerator is equal to 0, it's not affected. The denominator is the one that is affected. So meaning to say, for a condition where x is equal to 1, it can be considered as part of your solution where x is equal to 1, because directly when x is equal to 1, what is happening? F is equal to 0 at that moment. So it will give us a 0, therefore satisfying the condition that this here can be what? Less than or equal to 0. But we must be careful. It does not just be put equal to equal. No. Whenever there's a fraction, you compare. The denominator is not supposed to what? To be equal to 0. The denominator is not supposed to be equal to 0. You must take note of that one. So this is how they will be confusing you in exam. They will just put an equal to, then you are now putting their equal because you said your teacher told you that whenever there's an equal to, you must, yes, it is true, but there are questions where you must consider conditional as a condition. And another thing, here we are making a comparison with f of x, with what gx, in the denominator. The same question that we are having here can be given in a vice versa. If it was like this, if it was f of x, all right, if it was gx this time on top, gx over f of x, it means f of x is the one that is not supposed to be equal to 0. F of x cannot be equal to 0. So meaning to say that condition where it is -4, at -4, both they're equal to 0. So it means when it is like this, where f of x is in the denominator, x cannot be equal to -4 because f will be equal to 0. At 1, this point 1, remember 1 lies on what? On f. Where x is equal to 1, f is equal to 0 there. The y value is what? Is 0. So x cannot be equal to 1 again. When f of x is in the denominator, these two are supposed to be put into consideration. Then you can answer your question, but you must put note that this cannot happen. X cannot be equal to 1. X cannot be equal to -4. Once it happens, it means f is equal to 0. It will be like this: gx over 0. The denominator, remember, cannot be equal to 0. So that is what I'm trying to explain. All right, guys. So you see, that is how they ask these questions. They try by all means to confuse you guys. So do as many questions as you can. Revision matters. All right. As we were working with this part, we got solution from this region, and the other one failed. But that region that failed, it satisfies another region again. Let's say the question was specifically to determine the values of x for which f of x over gx is greater than 0. Being greater than 0, that means it's what? It's a positive. So it's either positive over positive, negative over negative. So the region that failed previously satisfies this one, which is this region from what? 1, 2, 3, 4, 5, and so on. Both functions are positive. G is positive, f is positive. But remember, we must also check to say is as we are dealing with the g of x cannot be equal to 0. So we must consider that one. But at point 1, it does not affect G because G is on top. It affects F because F at that moment is the one that is what? Equal to 0. Y is equal to 0 there. So it does not affect our question. So therefore, X will be greater than what? X will be greater than 1. That is from 1, the x-intercept going, and so on and so on. So this will be your solution, which is very, very important for you to take note when it is like that. When it is like that. So if it was f of x over gx is greater than or equal to 0, you were going also to consider, remember I said g is the one that cannot be equal to, and it is not affected where x is 1, our g is not affected, so g is safe. So it means x is greater than or equal to 1. Because of what? When it is equal to 1, it is f which is equal to 0. So it's like 0 over whatever that will be given. It'll give you a 0. So therefore satisfying what? Being equal to. But if you consider like this, guys, the moment you take it this way, the moment you just take it this way, gx over f of x is greater than or equal to 0 like that. The moment you take it like this, it does not apply because we are saying f of x is the one in the denominator this time, and f of x cannot be equal to what? Cannot be equal to 0, and it is happening at 1 there, where x is equal to 1. So meaning to say x cannot be equal to 1 when it is like this. If f of x is in the denominator, x cannot be equal to 1. So therefore, if we are to solve the solution where gx over f of x is greater than what? 0, we are taking values that are greater than 1. Both are positive, remember, for values that are greater than 1. So we cannot put equal to 1 because the moment we say it is equal to 1, it now makes this statement to be what? Undefined. So that is, you are not going to put that one. Whether it was asked, it was there on your question to say, is greater than or equal to 0. No, you do not put it here. Because of what? How the question will look like. It will be undefined. So maths, guys, be inside of it. Be inside of it. Enjoy the subject. Be part of the subject. All right? Understand it. Do as many questions as you can. All right? So let's consider some typical questions which are exam related. So here I'm just going to take the important part, the diagram and the question. Determine the values of x for which this gx over f is greater than or equal to 0. All right, this time we have there is f of x, a parabola, and we had the gx, which was a hyperbola. Remember, I said for a hyperbola, you must consider the asymptotes as part of the critical values. It's not going to be just x-intercept, but also the asymptotes, they have a role that they play. So be very careful about what? The asymptotes, all right? So considering this question, we had the asymptotes at C. That is at C, we just need the x value there. At C, it was minus, let me put this one at A. It was minus 4,65. At B, it was 0,65. And at C, it was minus 2. The value of x at minus, at C there is what? Minus 2, which is an asymptote. So if we consider, let me just put it this way so that we can quickly have our question. It's not even that much, guys. Just have to be very careful. So remember, I said we need the x-intercepts and also the asymptotes. Since this time we have what? We have a hyperbola. So this was it. This is an asymptote here. Okay, this is an asymptote for x is equal to what? X is equal to minus 2. So that was what we're having. So without wasting your time, we need the condition where we are going to have gx over f of x. Gx over f of x. It is greater than or equal to 0. Don't be tempted because they said equal to 0. Then you want to put that equal to. Check because here f is the one in the denominator. So remember, the denominator cannot be equal to 0. So thus f of x cannot be equal to what? Cannot be equal to 0. If f of x cannot be equal to 0, remember we are dealing with what? The intercepts here, x-intercept for the quadratic function. We're going to take our x-intercepts, which is at A, that's our x-intercept. At A, it's an x-intercept. At B, here it is also an x-intercept, all right? Considering at B, which is 0,6, whatever that you have there, at B, it is what? The x-intercept. So the asymptote becomes part of our solution as well because it limits the other boundaries. So as you have got the critical values, we have got the x-intercepts and also the what? The asymptote is supposed to be taken into consideration this time. So meaning to say x is equal to minus 2. This asymptote is also part of your boundaries. It is also part of your critical values. So this time we have got about 4 regions. This region, all right, then this region from minus 2 to 0,6 at B at the x-intercept, that's the third region. It's another region. Then values that are greater than 0,65 like this, that's the fourth region. So there are 4 regions that we are going to compare our solution to get positive. Greater than 0, it's positive, positive. or negative, negative dividing, all right? But remember I said f of x cannot be equal to 0 as it is in the denominator. What are those values that limits our f of x to 0? When it is equal to 0, you will be in the what? You will be in the x-axis. Meaning to say we're talking about the what? The x-intercepts. So according to our solution, whatever that is on f, whatever that is on f, as long that is equal to 0 in the x-axis, it does not work. Meaning to say at a minus 4,6, x cannot be equal to minus 4,65. And also at b, which is the x-intercept, x cannot be equal to what? 0,65. Whether they are part of the solution, but it cannot be equal to that. It can be greater than, it can be less than, but not equal to this. Because once this happens, f of x will be equal to 0. And thus our denominator is equal to 0, which is what? Undefined. So that is the first thing that you must put into consideration. So these values are actually excluded as part of our answer. It can be greater than that, not equal to. No, 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 no. It can be less than that, but not equal to that. So now we can answer our question because we have got restrictions that we have. And also the asymptote. It's another part. This one does not affect f of x, but it affects g, the asymptote. That is the reason that why I said you must have an asymptote because it affects g. As for gx, x cannot be equal to minus 2. It is limited. So that's another thing. X cannot be equal to what? Minus 2. This one is for the what? The asymptote now. It has nothing to do with the type of the graph to say g on top is 0. No, it's about the asymptote. X cannot be equal to minus 2. All right, so that is it. Let us answer our question. Which part that we need where both are positive or negative? All right, the first region, guys, there is no comparison because of the asymptote. Take note, our asymptote, it's here. So it was actually supposed to be like this from the idea of a hyperbola. If you've got a shape here, you're gonna have another one this side. So it was gonna be like this, limited to those asymptotes. Again, it was gonna be something like this in this region. It is part of this gx, your hyperbola. So you're going to notice that, let me put it this way. Let me put it this way. You are going to notice that according to this region that we are having here, it is not part of your diagram. It can satisfy other values, but it is not part of what you're given there. Yes, it can satisfy other conditions, which is not part of the solution. So as you consider this region, do not focus with this part because it's part of the graph. When you were asked for you to draw it, the question is draw it. You are the one who is supposed to draw it. In that case, you can consider that part. But in our case, guys, we are not given that. So we're not going to focus on that region. We focus on what we are given. So this region, 1, it is out. 2 is also out since we do not have anything for comparison. It is just F. Just F. Just F that we have here. G is not found. We do not have G. We do not have G. The G part, according to the diagram, to the sketch that we are given, the G part starts at what? X is minus 2. That's where we see this shape. So we are going to make comparison from minus 2 going this side. All right. So from minus 2, let's check what is happening. Our G is above the x-axis. All right. This is our x-axis. All right. So G is above the x-axis. As we can see, our G is on top of the x-axis, being positive, and also F is above being positive again. That's from -2 up to what? Up to 0.65. Both are positive. From 0.65, the x-intercept at B there, F is now in the negative region below the x-axis. It is negative. Whereas our G is still positive on top. It cannot go beyond, it cannot even go beyond the x-axis, as we have got what? An asymptote there. So it is limited up like that. So it's going to be forever positive where it is. It's going to be forever positive. So from 0.65, G is positive, whereas F is negative. All right, our condition here is we need where both are positive or negative. So both are negative, both are positive here. In between, -2 at the asymptote, and B, the x-intercept in between. But remember what I said, here we must have a comparison when we are to answer now our question, because there are other conditions that x cannot be equal to -2. So x is going to be greater than, between -2 and 0.5, 0.65. X is greater than -2, but less than 0.65. Can it be equal to -2? No, because it is an asymptote. So you cannot put that equal to, even though it is there on your question. But from the diagram, this question, that is why it is graphically, you answer from the diagram. You don't answer your own way. No, from the diagram. So x cannot be equal to -2. At the same time, we said x cannot be equal to 0.65, as at 0.65, our f, the one that we are referring to in the denominator, at that 0.65, it will be equal to 0. So it means the fraction becomes invalid, undefined. So x cannot be equal to this. So this will be our final solution, that x is greater than -2, but less than what? 0.65. Answer the question, guys. Answer the question. Mostly you are limited because of not answering the question. You answer what you have been taught in class, of which exam is not what you have been taught in class. Exam is application, is the mind of another person. You read the mind of the examiner, understand the mind of what? The examiner. That's something else, different from what you have been taught in class. All right, anyways, let us consider another part. Here we have got these two graphs. Use the graphs to determine the values of x for which f of x over gx is greater than or equal to. They put an equal to there for temptation. All right? So we have to analyze first. What we are dealing with, these are just normal. We do not have a hyperbola, so asymptotes are not to be taken. Our critical values will be just what? X-intercepts. So that is it. This is it. Our x-intercepts, it is here. It's an x-intercept at -2 and x-intercept here at 6. Those are the critical values. We do not have just like a hyperbola where we have got an extended part of asymptotes. All right. So these are the critical values at -2, x value at -2, and the x value at what? At 6, the x-intercept, just like that. So let's compare. We need this to give us what? We need this to give us a positive greater than f of x over gx, for it to be greater than or equal to 0. That's being what? A positive. So we are back positive over positive, negative over negative. But take note, gx is in the denominator. Gx can never be equal to what? Can never be equal to 0. So if we check where our gx is, we must consider our gx. Gx is the straight line. This is our gx. So where is it equal to 0? gx is equal to 0 here at what? At minus 2 in the x-axis. At minus 2. Gx will be equal to 0 at minus 2. So therefore, we are saying x cannot be equal to minus 2 because at minus 2, gx will be equal to 0. And we do not want it to be equal to what? To 0. All right. So anyways, this is it. Let's compare the two graphs at positive 6. Here, g is not affected. At positive 6, it is f, which is at 0. F can be 0, not a problem, because it's in the numerator. We are focused with g. G at that moment at 6, it is giving us a certain value, which is not what? Which is not 0. So guys, we can answer our question. That is it. We can answer our question. All right, there are three regions formed from this one. There's this region. There's the second one in between minus 2 and 6, and values that are on the other side of 6. So values that are less than minus 2, this minus 3, minus 4, what is happening? Comparing with the x-axis, we can see that both graphs are below the x-axis. Both graphs are below the x-axis. If we check properly, our f here, this is our f. It is what? It is a negative. This is our f. It is in the, this is our f. So here at minus 2, it is in the negative region, where our g, the line also is in the negative, below the x-axis. Both are negative. So that's exactly what we want. So the first one is going to work. The second one, all right, f of x. All right, the second one from 2 to 6. All right, the second one from 2 to 6. 2 to 6, we can see that also both here, f, this is our f. F is positive on top of the x-axis, and g is also positive on top of the x-axis. So f is positive, g is positive. This is exactly what we want. So the second region is part of our solution. The third part from 6 here, going to the left, we can see that here, f is now in the negative, all right, below the x-axis, whereas g is there on top, still positive above what? The x-axis. So we do not want that condition. So the last region is invalid because positive times negative is not going to work. But positive times positive gives us a positive. Negative times negative gives us what? A positive. So therefore, our solutions to this question, values this side, they are less than what? They are less than minus 2. Are we going to put an equal to because it's there? No. Because we said x cannot be equal to minus 2 because of that denominator concept. Gx will be equal to 0 that time. So we cannot put that equal to here. We cannot do that. But we can just write x is less than negative 2. Or another solution, in between minus 2 and what? In between minus 2 and 6. So it means x is greater than the smaller value, minus 2, but less than 6. But let's consider 6, because we are supposed to have an equal to at 6. Does it affect our gx? No, it is only at x, which is minus 2. So meaning to say x can be equal to minus 6. It does not affect, because when x is minus 6, it is f which is affected. At that moment, f will be equal to 0. So whether we've got 0 over 1, we're going to get a 0. 0 over 2, so it satisfies that it can be greater than or equal to 0 at that moment of what? Where we have got 6. That is it. But minus 2, totally out, it cannot be equal to minus 2. What is in the denominator matters. What is in the denominator matters here. So don't rush when answering these questions as an individual. Understand your question. So where you do not understand, Let us communicate. That is why we've got the community section. Let's communicate. Let's answer. Let's ask those questions. Then we're going to use the same platform to answer those questions that we have asked. So that is it, guys. Till we meet again.